Hi guys, my name is Michael. For convenience of me speaking not so loud, maybe you guys can shift to the front a little bit, that'll be cool. Don't worry, I won't bite, I won't bite.
Mike. We know he doesn't bite.
I don't bite much. Okay. Hi guys, my name is Michael. I'm going to share with you guys a little bit about continuous integration, or CI, for PHP using Jenkins and Sona. So, just a show of hands, how many of you guys work in the development team? Right, team players? Okay, sweet. Right, so this is probably something close to what you guys probably want to have in your enterprise. How many of you guys are already using CI in your own company? Right, so a couple of hands. Sweet. Okay, so if I make any mistakes, feel free to correct me. Right, so the agenda, what I'm going to share a little bit about. So I'll give a brief overview of what continuous integration is all about. I'll share with you a little bit about Jenkins, Sonar, and also about the QA tools that are available for PHP. I assume the guys in this room are PHP developers, yes?
No.
Okay. If you're not, it's okay. We like you too. Okay, so what is CI? CI, in my own words, is quality control as a continuous process. Basically, you're committing small chunks of code together into the repository, and rather than at the end of the development cycle. So what happens is that continuously, as you commit code into the server, all the codes from all the members in your team are put together and checked together and make sure that they will work together, right? So what this means is you're merging smaller and manageable chunks of codes on a daily basis, on a regular basis, not just at the end of your development cycle. So how many of you guys have actually worked in a team where after working for an entire month of work, or maybe after 2 weeks of work, all your codes start to merge together? Oh, merge conflict. This library wasn't used at all. No, why did you delete this file here? I was using that file, right? So, it happens to a lot of us in our company. Which is why in big companies, they are actually merge QA people who actually, their full-time job is nothing but merging code. Right, on a regular basis, oh yeah, we're releasing this in 2 weeks' time, so we need a guy to, oh you, come here. So you sit down at the desk, you pull everyone's code together and start, okay, conflict here, conflict there, is this needed? No, what? Right? So, at the end of the day, you have another branch, oh, okay, that's ready to go. Wait, that's already 2 weeks of merge QA. Oh wait, new code is coming. Shit. You really gonna do it again? Yeah, so that's the pain that most people go through. And CI is not a silver bullet. It doesn't solve everything, but it's an attempt to make it a bit easier. Some of the important ingredients, if you don't already have this, I encourage you to go get it. Make sure you are using a version control, right? Earlier on, CJ shared with us about Git SVN, so if you're using Git or SVN, whichever you're using, that's cool with us. In my previous company, we use a Git version control software called Dax. Any Dax users here? No? Okay, no. Thomas is not here, he'll be so happy. Okay, anyway, so version control is very good for helping you maintain versions of code together. And make sure you have some self-testing code. Basically, you have code that you basically write tests for your code. Test-driven development, behavior-driven development, even Selenium tests, or you have some JavaScript tests or something, How many of you guys actually write tests? Okay, it's about time to start. Okay, and also have an agreement in your team. Like everyone in your team knows, have an agreement in your team about what is your development processes. Basically, okay, so why am I going to merge code here? How is it going to go into production? How is it going to go into whatever? Having a management tool like Pivotal Tracker or Jira is very helpful in helping you get things right, making sure that you track what's happening and what's going on in your team. And also, a project management tool like Pivotal Tracker is very good for getting your business owners in on the game. Right? So business owners come into the game, oh, okay. So they don't have to keep bugging the developers, right? So where are we now? Oh, is this part of the project done? Just take a look at the Pivotal Tracker or the management tool. Everything is there. And Jenkins is actually one such tool, which you can see that, oh, okay, like what if you guys were in Kelvin's talk earlier on, he was talking about if you're project is building properly, it's green light. If something's broken, you see a red light. Something similar in Jenkins as well. So, and also have a proper branching strategy. This is actually a part of what we talk about, the agile processes, make sure that your team wants to adopt. Make sure you guys have an idea about how do you roll out a new branch, how does that branch translate into a production branch. In my previous company, what we did was, after every release, we'll cut a new RC branch, and that branch will be the development branch that everyone works off, commits to, checks out, and writes to. And once that is done, and there's a CI server that checks this branch every day, every hour, every 5 minutes, I think. So, and then after that, once it's ready, this is the one that goes into production. And once it's out there, you merge the trunk, and we cut a new RC from there. So that's real DevOps kind of thing there. So you've got to work with your team to get it right. Continuous integration in action. So basically, there will always be a main line in your code repository that you check out. Everyone in your team checks out from this main line. It could be a new RC branch, which I said earlier. You checked out you create a new RC branch, and that will be your release candidate for the next version. Everyone checks in code, checks out code from there. So that happens every day, or at the beginning of the workday. You checks out the code or updates your local repository. Go through the TDD process: write code, write test, fail test, write code, pass test, refactor, You know, the whole make it green, make it clean, and make it green and make it clean. Right? So after you're done, commit the codes locally. If you're using Git, that's fantastic. Because Git, make sure you're checking code into your local version of the repository rather than throwing everything to the server. Mercurial actually does something like that as well. Dax does it as well. Why this is good? Because when you commit things locally, you can just run the test locally as well. Actually, to be strictly speaking, you don't need to commit the code to run the test. So you run the test locally for the parts of the code that you've written. Make sure it's working. Once it's done, check commit it. Then you pull the changes from the server. Basically, everyone else is working on the same code at the same time, right? So you just pull everything down, run the full suite of tests that everyone's working on. Make sure you pass locally, then you throw it up to the server. And that the CI server does the build, checking, and all the other stuff for you. And when something breaks, you see a red light blinking. Or in Jenkins, there'll be a cloud, there'll be actually a red dot. You see a red dot, okay, this build has failed. Everyone should now get into action and try to find out what's going on. So, oh, this last person who checked this in, okay. Right, let's go flog him. No, I'm kidding. So we go and fix the code problem, make sure the test passes again, and throw it back in. Get the most out of CI. Okay, some of the things I've gone through in working with continuous integration. It's important to keep your stories small, your user stories, keep it small and granular, so that what this translates into is smaller code change sets. Smaller code change sets means you can commit more on a regular basis, right? So in your iteration planning meeting, make sure you have really good detail about what's going on, break it down into small chunks, file the tickets that you need in Jira, Pivotal Tracker, make sure they are small. Pivotal Tracker I kind of like because you can actually, once you set the sizing, you can have a good idea, okay, how big is this story? If it's too big, it's time to go in and just break it down in smaller chunks, right? In Jira, I'm sure you can do that as well. So having a good tracking tool or project management tool helps you in getting all these things done. Right, and merge early, merge often. This reduces the pain of resolving conflicts later. As I said early on, if your development cycle is long, everyone's working on different branches. Once it commits at the end of the development cycle, find conflicts, code changes are not in sync with each other, that's painful. So merging it early, and making it often, and automating the whole process is actually a very big time saver and less pain for you guys. And also write tests that runs fast, because nothing bores the hell out of you rather than clicking run test and you sit back, play a game of Minesweeper, run a few rounds around the track before I come back. Oh, it's still running, right? That's just boring. Right. So one of the ways to make your test run faster is to write mocks and use test doubles so that you can make it run faster. So because one of the reasons why some tests take a long time to run is because it has to communicate with external services like Facebook API, talk to Twitter API, or something else, right? those things are, the network latency is beyond your control sometimes. So reduce those by creating more objects so where you ping instead of hitting the actual database. Right, and automate. Why we use CI, Jenkins CI is to automate things. In many startups, you don't have the resources to dedicate to have one person to be the merge QA, for example. Right, so you need to basically, everyone has to play double roles, and you can offload the role into an automated process, like using a Jenkins CI server, or any continuous integration server for the matter. It's a very good way to save costs and keep your sanity. Right? Okay. So after all that, what is Jenkins CI? Well, it's an application that helps you execute repeated jobs, right? And basically helps you, it monitors execution of repeated jobs, right? I can show you how it looks like right now. Right, so this is the website, jenkinsci.org. And this is an example of a Jenkins. Right, so this is an example of a Jenkins screen, dashboard. And each one is basically a project that runs on a regular basis, or is as easy as a push button. What this thing does, which I'll show you a little bit later, full test basically is an example code which I wrote. It's on GitHub. You can check it out later if you have time. Which basically checks out the code and runs a build process on it. It runs the tests. It runs a couple of QA stuff, which I'll go into a bit detail later on. Okay, so that's CI. Jenkins CI, sorry. So what is Sona? Sona is, as much as I like Jenkins CI, is great, but the reports that it generates are just crappy, right? Let me just show you a sample report of what is. Okay, so this guy here, these are the bunch of graphs that it generates. It's kind of messy, it's all over the place. You can check out the coverage report. Okay, this is, see the interface you brought out of the Jenkins dashboard altogether. It looks functional, right? It works for some people. You can check out your API documentation, and stuff like that. But it's not pretty. It's not pretty. It's functional, but it's not pretty. Whereas we have a software called Sona. Sona is it kind of like it prettifies your logs. What it does is that once you run the Jenkins build and everything, it generates a whole bunch of log files. Sona will suck all these log files in and basically generate beautiful charts, pretty charts that everyone in your guys from your business guys could look at and say, oh, that's pretty, it looks good, lots of green, that's nice, which is good for management. And also, it's also quite interesting in that Sona can be used for other projects as well. So you have a Java application, a Python application, all that. As long as it generates some form of log files, Sona is a good way of consolidating all these little charts and make it look pretty, and also present them in a consistent UI, which makes sense, right? You go to the Sona website, sonasource.org. There's a link to a little open source project which they have. It's called Nemo, which basically shows you all the different projects which they are building. Like here's one for Apache. It tells you the line of code. Is it click to the middle? Right. So it has certain reports like line of code, how many classes it contains, for example. Documentation shows you the coverage. Anyway, yeah, so it has some pretty nice graphs, Ooh, pretty numbers, they move around. Okay, yeah, it makes sense for some people to look at this. Some people really like to see, it makes sense for you as well as a developer. Yeah, which of course, as I said, Jenkins does give you those charts, but it's kind of not very pretty, right? Okay. Right. Yeah. So that's Sona. Any questions so far? Everything okay? Okay. Great. Yeah. So this is an example of some of the charts that they have. So let's get into the meat of it. QA tools for PHP. Okay. So all that Jenkins sounds fine. Sona sounds fine. So how do I use it? It can be a little bit painful to get it set up sometimes because there's a lot of things, a lot of forms you need to fill up. So this guy who created PHP unit came up with a template, a Jenkins template which you can use and drop into your Jenkins CI. It basically creates a template which you can just copy, duplicate, and then use that to set up your stuff. And it's pretty big in the sense that it's like a kitchen sink of QA tools. Right, it has a whole bunch of tools that helps you, that checks for the cleanliness of your code and stuff like that. And it uses Ant, Apache Ant. It's kind of like a bash script or a batch file on steroids. Kind of cool. Okay, but it doesn't compile PHP unless you're ready hip hop. Okay, nobody gets a joke. Okay, now right. Okay, but yeah. So these are a bunch of tools that you can create, rather the QA tools. It comes with the template. So there's check style. It checks for whether you're using tabs rather than 2 spaces or 3 spaces. Or the best part is that it's an XML file, a style checker. You just update the XML file. It has a whole bunch of settings you can change. It will check, oh, if you're using tabs, that's wrong. You should be using 2 spaces or 3 spaces or 4 spaces or whichever for tabbing. Dry is basically checks for duplication. There's mess detection, checks for amount of dependencies in your code. XUnit basically processes your PHP unit logs and gives you a sense of how much coverage you have, or rather how well your test passing or failing. Clover PHP, which basically generates that pretty nice coverage report that you have. HTML publisher, which creates an API documentation for all the PHP codes that you have. So it sucks in all your PHP doc logs, and converts them into nice documentation in HTML. And also creates charts. Right. Okay, so if you're interested, I've created a Git repository for this. This is actually based on the TDD presentation I did some months ago, right? And basically I've extended it further to basically allow the build on a CI machine. Right, so here you have the template for Jenkins jobs. As you can see, it's quite detailed what one can do. Setting up is also quite straightforward, right? So basically, some of the things you need for installing Jenkins and a CI environment. First, you need an operating system that supports Java, because Jenkins CI and Sona runs on Java, unfortunately. But it's cool. Yeah, so I'm using CentOS. You install Java in your CentOS box. You have installed Jenkins using Yum, for example. There's a whole bunch of QA tools you can install, the PHP QA tools. So once you've installed, that, you basically just need to run something like this, which will basically configure all the tools that you need, those tools that I talked about, all the kitchen sink of stuff. You don't need all of them. You may not need all of them, but having them there, I don't know, having them there may give you a false sense of security. But you know, it's good to have. Okay, so once you install that, it also includes instructions on how to set it up on your machine. Basically, Jenkins CI can configure a whole bunch of plugins. You can install plugins. Git support is not available out of the box, so you need to get Git support in there. You also need to get all this other stuff that is written here into Jenkins as well. Also, yeah, to do that, you basically need to go to Jenkins. You can install Jenkins if you're on CentOS, you can just type yum install Jenkins. If you're on Ubuntu or Debian, I'm sure you can get apt-get install Jenkins probably somewhere. You can also download the WAR file or jar file, which you can then just run off the console. And it usually opens up in port 8080, right? Right, so you can actually manage Jenkins and add the extensions that you need. Right, for this particular project that I worked at, this sample code, I require Git support. So basically I have to install that first by going to Manage Jenkins, Manage Plugins. Right, so I do a search for under available, like Git. Right, Git. It also supports GitHub. If you have your application committed into GitHub, you can do that. Check it out from here as well. So once you have all that, once you have Git installed, you can basically check out the PHP template. So if you use the command line tool as part of Jenkins, you can just check out the command line. You can actually install the new template and make a copy of it. Once you make a copy of it, for example, I create this full test. So what you do here, you can set it up to run on a regular basis. Or in this case, I'm going to just going to start a build. Let's see. Right over here, build now. Go. So what this thing does, you can actually check the. Where is it? Where's the console? Okay. Ooh. Okay, you failed. Which is a good thing, actually. You failed. Okay. Right. That was a negative demonstration. I'm sorry. I apologize. But yeah. Why did it fail? Let's look at it again. Build now. Check out the console. That's what it's doing. So what Jenkins does is it checks out your code from Git, put it into a workspace, a folder, and then it runs the tests that you need to run. For example, in this case, it's actually supposed to run an Ant build, basically an Ant job, which will run a PHP unit and a few other things. Right, there's no network connection, so that's why it failed. Haha.
Yeah, the Wi-Fi logs you off every few.
Yeah, okay, right. I'm running it off a VM here, so the VM doesn't know how to connect to the internet. Okay, that's unfortunate. But no worries, let me just try and run this. There's a backup. I have a backup plan. Okay, so right. So what you should have done was actually basically this. This is what you should have seen in the console, right? So let me just scroll up and show you what it actually did. So it reads off a file called build.xml, which comes as part of the template. So the template itself will tell you, okay, this will be building a couple of stuff. In this case, first of all, it cleans up the directory in which it was installed in, prepares a folder that it needs to dump all its files into. Next thing it does, it checks your code. For example, in my test code, there's only 3 files, which are PHP files, which basically you check it for syntax errors, right? So if someone in your team accidentally checks in a code which has syntax errors, the build will basically tell you. It basically checks every single file in your system. Next it does, it checks for, it gives you some statistics about a line of code. So in this case, my little project here has only 167 lines of code. In a bigger project, you probably have a few 100,000 lines of code, which is quite normal. you're using a framework, probably the framework also contains a whole bunch of stuff. Okay, so next it does, it checks for dependency, and it checks for messiness. Next it generates a whole bunch of graphs, right? And then it finally runs the PHP unit test. Okay, so in this case, it had passed all the tests. But in my, yeah, so this is what it should have run. But having this also gives you give you an example of how it would look like if the test failed. If the test is failing, you see a blinking red dot. As you can see from the bottom, if it's a blue dot, it tells you that, okay, all the tests are running, they're passing, you're good. Right? And the next one, if it fails, is a red dot. Right? And it gives you and also once you go back to the dashboard, it gives you a sense so where you are. Build stability 3 out of 5 builds has failed. So this is what could be a symptom of what's that some of your developers are not doing a thorough job of checking their code before they check in. Yeah. Right. So it will tell you that you will see something like this, a red dot. You know there's a problem. Your team has to go in and find out what's going on. Or you check who is the last person who committed the code, find out what's going on there. Right. Okay. And of course, once all these logs are sucked in and used, you can actually see how they look like. For example, the PHP, the Clover HTML report that gives me the sense of the code coverage. My test has actually covered my PHP unit test has actually covered pretty much a whole good chunk of the code. This is not realistic because this is just a small project, so yeah, it's not realistic. Okay, so yeah, so all this data looks pretty messy over here. All these log files can all be sucked into Sonar, and then you see them as nice charts like this. If you check out my code from GitHub, I've also included a shell script on how to set up Sonar on your machine. So you can actually use this as a means of getting it set up. Okay, so Sonar has a couple of quirks, right? So the PHP template 2 that you saw earlier, it uses the latest version of most of the QA tools that you see. With Sonar, because of some backward compatibility issues, it uses some older libraries, but it's still kosher. It's still quite good in that you can use it. Right. Okay. So to get set up with Jenkins, right? You can install it in your VM, or you can set up a build machine in your company. Set up the build machine, which will basically run a cron job. You can install CentOS on it. It checks out the code, runs the code. In my previous company, what we did was we have a AWS instance that checks out our Dux repository or Git repository, and then run the job on a regular basis. We had to support. Okay, and it's not just about building the tests. You could also use Jenkins for deployment. So in my previous company, we had one job that does the test runner, another job that builds the Debian package, another job that deploys the Debian package to staging, and another job that deploys the Debian package to production. So it's about four Jenkins job for each one. And anytime the build fails, you will actually see it on our Jenkins console. Unfortunately, that console has been taken down since the company is not in. Yeah. Anyway, but saving grace. If you guys want to try it out, I would suggest you check out this nice little platform as a service from Red Hat. It's called OpenShift, and one of the built-in tools that you can start up and run is a Jenkins instance. So you can add an application, and one of the options here is you can actually set up a Jenkins instance. Scroll down, you see it somewhere here. There you go. So you can spin up a Jenkins server. And this is an example of what I've done with it. So, yeah, so you just like click on a button, deploy a Jenkins machine, and all your other projects can be built here. Right. I'll show an example here. This one basically checks out a cake PHP project, also on OpenShift. And this one is a bit more interesting because I'm going to show you next is the configuration is actually quite verbose. But one thing you can do in your configuration of this Jenkins job is you can set up, you make it run some shell scripts. Right, you can run shell scripts in your box. You can do all sorts of shit with it. Right, you can check out stuff. You can do all sorts of stuff. So that's one thing you can check out and have a look at. Right. So any questions so far? No? Yes. Hi. Sorry. Okay. The project started out as Hudson CI under Sun Microsystems. And once Sun was bought over by Oracle, the team that was working on Hudson CI was in agreement with what Oracle was taking the project. So what they did was they forked the project. So Hudson CI and Jenkins CI are actually the same monster, but Jenkins CI is the latest development. I think all the developers who work on Hudson CI has now shifted to Jenkins. Right. The plugins should work. Plugins that are built for Hudson CI should work on Jenkins CI. So that's good. That's good stuff. And it still needs Java. Right. Of course, a CI machine doesn't have to be. You don't have to use Jenkins if you don't like Jenkins. There are also other CI options out there. There's cruise control. There's also a very interesting project that's on the internet now. It's called Travis CI. Travis CI is an open source continuous integration service. It's basically a hosted service, but it's public. So what happens is that, for example, the CI sample code which I created on GitHub, I think it currently only supports GitHub if I'm not wrong. So on GitHub, I can actually make it run the test or run the build. So I can tell it, okay, I need you to build it now. Can it build? So it's built. Oh, okay, sorry, it checks for changes in your repository. This is kind of cool. Travis CI will actually monitor your repository and look for changes. I think I committed a change about 4 hours ago with one file. And basically it ran the PHP unit test internally and tell you whether it's pass or fail. Unfortunately, you don't have access to, you can't install, there are no like beautiful charts you can create or reports you can create. Because I think at the moment it's still quite limited. But Travis CI can support other forms of code sources. If you're writing Python or Ruby and stuff, you can use this as well. You can see all the different projects are being built here. These are all public repos. So kind of cool. Yeah, so that's all I have. Any other questions for me? Okay.
Michael, I've seen some GitHub projects that this little like what do you call this little like what view status passing, view status failing. Yeah.
It's Travis.
Okay. I see.
Right. So in some GitHub projects you see a little status there is actually coming from Travis CI. So that's kind of cool. I think there's another service called Olo, but Olo tracks the number of hours that is worked on the code. Right. What else is there? Yeah, so if you check out my code, there's actually a copy of setup Sona here, so I think pretty much covers everything that I use. So, right, so that's all I have, I think.
Michael, did you explore the ping for the PHP based build system? Ping, PHING.
PHING. There are a couple of PHP build systems out there. Ping, fake, or make, fake, make. Yeah.
Fake.
There are a couple of those things around. So It's interesting. Oh yeah, I probably should show you the code. This is the build.xml file. So basically, it has a whole bunch of stuff. Like you basically tell it to do various jobs like clean up. Please delete this folder. Further down would be the lint portion, which checks the syntax. So it's an XML file which you can edit and optimize, or even throw out chunks that you don't need. Say, for example, you're working on a very old code base, and the messiness and duplication there is quite hair-pulling. So you might want to remove those things because it depresses you. Or you can make it just run on newer stuff, right? So that's what we can do. So you can actually run, you can also run these jobs in parallel. So what I did here was I ran a couple of stuff in parallel. So a couple of jobs can run together. Saves time. Right, so that's all. This is V. You can find me here in these places. Right, so I work for Make Delivery. We were hiring PHP developers and Java developers, I think. Yeah. So yeah, yes.
Where to find those tutorials of Jenkins? I think it's very hard to learn, to find tutorials online. To how to configure like XML.
Tutorials online for Jenkins. I've not found one.
Yeah, I didn't find any also.
Yeah, it's I don't know. To be honest, when I did Jenkins on my own, it was a bit of a head banging kind of experience. Although the template is actually very helpful. The template from Sebastian Bergman is very helpful, as it gives you a lot of details how to get it set up. Yeah, but once you have this thing set up, configuring Jenkins to get everything in place can be a bit of a pain. Yeah, but I can just show you the configuration here right now. So this one copies straight from the template, so I didn't have to change much, except change it from using SVN to Git. So I just tell it, okay, now my repository is here. Please check out the codes from here. And then what I did was, yeah. So all the stuff here is pretty much already there. A few things you may want to look at and configure on your own would be the other settings files. For example, for the CI, okay, for example, code style, you probably need to create one yourself, and because this XML file will tell Jenkins, okay, how strict you want this thing to be. In Sonar, interestingly, Sonar uses quite a few libraries. Let me see if I can find my Sonar instance here. Where is it? Where is my Sonar? There, close it. We should try to close it. Local tools. Sonar. Okay. Okay, so you can actually go in and check configuration. Right, the PHP profiles, these are different profiles that you can use. You can use the pair profile, which is the code styling and stuff. Sonar way, the Zen profile, these are basically directives. Class has too many children, class has too many dependencies, all that stuff is here. Right, and because when you set this up properly, it will mark those as major problems if it's not in compliance. So that's something that Sonar can do for you. I'm sorry, I'm not able to go too deep into Sonar. Just pretty much. I'm also learning how to use it. I'm also in the beginning stages of learning it. Yeah, so right, so that's all I have. Any other questions? No? Yes? Yes, sir.
Deployment question. So when a system like Jenkins deploy a project, do you usually get it to deploy only the change files, or do you deploy the whole chunk?
For deployment wise, sometimes what we do is usually we'll package the entire repo into either a RPM file or Debian file, and then just push it over. That's the commonly used way of doing it. You can always do a checkout, right? Because as I said, Jenkins, you can rewrite a bunch of shell scripts in there. So what you could theoretically do make your build server log into the production server and tell CD to the folder, git pull. They will basically pull the stuff down from you. There's one way of doing it. There's one way. I wouldn't say it's right or wrong. This is to ensure that you pull this, just a diff. Although a clean way of doing it is to actually build a RPM file or a package or Debian file, then deploy it. When we were in my previous company, what we did was we set up a private aptitude repository, private Debian. We set up a private aptitude repository, right? And basically we will tell the server, please update apt-get update, which will basically pull the latest version of the Debian file and install it locally. Good thing about using package management for this kind of thing is that you can roll back easily. Tell it, okay, like for example, if you're using RPM UVH old package or something, you will basically move back to the previous version. So if you need to roll back, using a package manager is a very good, easy way of doing it. Of course, if you're using Git or whatever, you can actually check out the previous RC branch, which will give you back the previous files. But if you have files already written, there's some dependencies of. Good thing using package manager, you can run tasks before and after to say clean up the folder and stuff like that. If you're just doing a git checkout, there's no such thing. You could theoretically create a post hook or post commit hook or something like that, post checkout hook, but that's just messy. So I feel that's messy, right? So, yeah. Any other questions? Yes. Email. If you continue to fail, then you just spam out with all the failure emails. I think you got to adjust your cron job such that it will not, once it breaks, it will stop running the job automatically. But we still want it to build. You still want it to build. I think there are some other ways of doing it. Sorry? Build XML. Depends on how the email is triggered. If the email is triggered by Jenkins, there's not much you can do, right? Whereas I think what you can do. I think there's a couple of plugins in Jenkins that you can use for that kind of notification. So if you don't use Jenkins on built-in notification, you can use. There's a plugin that can do all sorts of funny shit. You can actually ping an API or ping some other thing. So there are additional plugins you can install for this. Yeah. Any other questions? No? Okay, good. So this is the PHP user group. There's a PHP meetup coming up soon on the 12th of September. Yeah, so will be happening at PayPal, I think. Yeah, Suntec City. So if you have not signed up for it, sign up for it and join us. Right, and thank you very much. I apologize if there's not enough information or there's something I have not addressed. I apologize. Do drop me a mail or tweet me or something, and I'll see. I'll try my best to give you an answer. Yeah, thank you. The slides are already available online. You can check them out. Yeah, the slides are available online. I think I tweeted it some time ago. Okay, right. Thank you, Lawrence.